Hi folks, this is the next video for the Year 2 Pure. We're looking at working towards 9F. Now this is the differentiating the trig functions. This relies on you having done chapter 6 during lockdown 1 appropriately. So if you haven't, you need to go back and do that. But I can remind you of some of the key points. We have these new identities, sec x, which is just 1 over cos x, cosec x, which is 1 over sin x, and cotan or cot x, which is 1 over tan x. And we deal with these quite a lot. That's all they mean. Like I say, I do urge you to go back and make sure you're all over chapter 6, because you'll be able to access this a lot more easily. Now it's worth pointing out that we're actually given the derivatives of these in the formula booklet. Let me find the formula booklet. Yeah, there it is. So in the differentiation section on page whatever, we're given derivative tan differentiates to sec squared, sec differentiates to sec tan, cot differentiates to cosec squared, and cosec differentiates to minus cosec cot. You're also given the quotient rule there, but we have looked at that briefly before. So I'll just go through the examples in the book. Example number 14. Find the derivative of tan x. Well, if we express tan x as sin x over cos x, then we can use the quotient rule here. So if y equals sin x over cos x, let's call u sin x, u dash then is cos x, v is cos x differentiates to minus sin x, and I'm going for u dash v minus uv dash over v squared. So dy dx, u dash v, cos x times cos x, that's cos squared x, minus sin x times minus sin x, so that's plus sin squared x, over v squared over cos squared x. Cos squared plus sin squared is 1, so it's 1 over cos squared x, which is sec squared x. And that's, of course, what the formula book tells us. It's worth pointing out, again, going back to the formula booklet, they've actually applied the chain rule for each of these. Tan kx is k sec squared kx. So tan differentiates to sec squared. Example 15 then, we'll use that fact. We've got to differentiate x tan 2x. Now I don't need to differentiate tan every time. I know that tan differentiates to sec squared. So this is clearly a product rule question. U is x, u dash is 1, v is tan 2x, v dash is 2, sec squared 2x, and the product rule, u dash v plus uv dash. So dy dx, u dash v tan 2x plus u v dash 2x sec squared 2x. And I'm just going to leave it like that. That was part A. Part B, y equals tan to the 4x. So I'm going to use the chain rule here, if you like. Think of it as tan x to the 4. Remember the chain rule, differentiate the whole thing, multiply by the derivative of the bracket. So dy dx is 4 tan cubed x multiplied by the derivative of the bracket, which is sec squared x. Don't really need it in brackets, in fact. 4 tan cubed x sec squared x. Example 16. Oh, sorry, that was example 15. Example 16. Y equals cosec x. Well, we need to show that it differentiates to minus cosec cot, so we can't just use that result. So let's write it as 1 over sine x and use the quotient rule. U is 1, U dash is 0, V is sine x, V dash is cos x, quotient rule U dash V minus UV dash all over V squared. U dash V is 0 minus U V dash, so minus cos x over sine squared x. Well, that's the same as minus 1 over sine x times by cos x over sine x, which of course is minus cosec x. Cos over sine is cot, so you can't see, there you go. Cos over sine is cot x. Done. Now we can find the derivative of cosec second cot in the same way, set it as 1 over, use the quotient rule, but we're generally given the results that we need. We don't need necessarily to remember these, we're given them. We need, of course, to know that they're in the formula book. Let's do example 17. Y equals cosec 2x over x squared. So quotient rule here, U is cosec 2x. Cosec goes to cosec cot minus cosec cot, so U dash is minus 2 cosec 2x cot 2x. V is x squared, so V dash is 2x. Quotient rule, U dash V minus UV dash over V squared. U dash V minus 2x squared cosec 2x cot 2x. The writing's got a bit small now. Let's do it down here. Dy dx is minus x squared minus 2x squared cosec 2x cot 2x minus u v dash 2x cosec x u dash v minus uv dash all over v squared x squared squared. U dash v, yeah, minus u v dash. Yeah, good. Okay. Well, I can simplify this. I can take out a 2x cosec 2x, can't I? So I'll do that. Equals minus 2x cosec 2x x cot 2x plus 1 over x to the 4. And I don't think, oh yeah, I can divide top and bottom by x as well, look. I'm not going to go any further than that though. It's about how far they got in the book as well, I think. So this is correct, simplified a bit. Sec cubed x, chain rule again. I'm going to use the standard result, sec goes to sec tan. That's from the book. So 3 sec squared x multiplied by sec x tan x, which of course is 3 sec cubed x tan x, because I've got sec squared x times sec x. Okay, that's example 17. I'm just going to pause it for a second. Hold on a minute. Okay, back, sorry about that. Yeah, this is an odd one, this last one. This doesn't tend to come up too much. I'll go through it so that we can attempt those examples in the book, but it's an odd one. First of all, we need to know that arcsine just means inverse sine. Okay, so if y equals arcsine x, that's just the same as y is inverse sine of x. So I can write that sine y equals x, because the inverse to arcsine is sine. So that's the first step to do. Let's write it in the way that we like it. Now I can't find dy dx directly, but I can find dx dy. Sine differentiates to cos. Remember that cos squared y plus sine squared y equals 1. So I can work out an expression. Oops, I wrote x instead of y. I can work out an expression for sine y. Sine y is the square root of 1 minus cos y. Well, that's x. So hang on a minute. Let's not do it. Let's do this. Cos y is the square root of 1 minus sine squared y. Because I've got sine y in terms of x. So the square root of 1 minus x squared. Dx dy is the square root of 1 minus x squared. Dy dx, then I just find the reciprocal. Now, again, we're given these results in the formula booklet. So it's not a disaster if we're not 100% on these. But certainly worth practicing those questions at the end of the exercise. More important, I think, is that we're happy with 14 to 17. Okay, have a go at 9F. Let me know if you need anything. See you soon.